Welcome. Today we'll learn why NFA, what is the definition of NFA, and some problems on NFA. Okay. So why NFA? What is NFA? NFA is a non-deterministic finite automata. So before NFA, what is DFA? DFA is a deterministic finite automata. That means it's a machine which contains the states where every state should take a transition for every alphabet symbol in the machine. Okay, but whereas in the NFA there is no need of that one. Okay, no need that. It has to only accept the language. No need to have to take the transition for every input symbol. Okay, so advantages is that constructing most of the NFA is very easy, and it's a non-deterministic finite automata which has the ability to guess something about its input, and it is more powerful than DFA. It has a power to be several states at once. Means what? Even the one state can take a transition for the same input more than one times. You can say here Q0 is taking transition for input A both to the Q1 as well as to the Q2. Consider this as okay. So like that also possible in the NFA. Nextly, an NFA is an efficient mechanism to describe some complicated language. Okay, so some complicated language. So here this is some of the example of it. So here Q0, it is taking transition for both A as well as B, again A. Okay, and here it is again. So there is no rule that every state to take a minimum only one transaction, and every input it has to take a transition. Okay, that is a plus point in the NFA. Language accepted by NFA. M, machine. Q is a number of all the possible finite number of states in the machine. Sigma is by alphabet symbols. Delta is a transaction function. So delta is Q star Q into all the alphabet symbols to 2Q. 2Q means the machine enters into one or more states. Okay, whereas in DFA it was Q into sigma to Q only. Means what? For one alphabet symbol it has to take transition for only one particular state. Okay, whereas here it can take more than one state, and Q0 is a starting symbol and F is a final set of final states. Okay, this is a proper set. This is a belongs to Q. Belongs to Q means Q0 should be one of the state in the given states. Fine. Let's see small problem. Obtain an NFA to accept a string of A's and B's ending with AB. Okay, so ending with AB means what are the possibility it can take? It can have minimum string AB, or it may have AAB, BAB. So in the front occurrence it can have any number of digits, means AB. Okay, that also should be accepted, and BB AB also should be accepted. But our minimum criteria means every string should end with the string AB, right? So this is a minimum criteria. Every string will end with the AB start symbol. Q0 is the starting state and Q2 is a final state. And now in the beginning it may contain any pattern of the strings, right? It may have any pattern. So we will just loop here with A comma B. So that means whatever the pattern it will come, it will be accepted by this language, and the rest will be, means always it will be reach to the final state after accepting A and B, means it will be ending with the string AB. So our final answer will be this one. Okay, loop will be there, A comma B and A comma. So this is our state. So Q means all the states in the machine. Q0, Q1, Q2 we have to represent in a state. Sigma is a symbol, alphabet symbol. So here AB is a symbols used. So AB. Q0 starting state represented by an arrow. That is our starting state is a Q0, and F is a final state, that is accepting state represented by a double circle. Okay, and Q, it is shown in this transition table. So transition function starting state arrow, star is a final state. Final state is our double circle representation Q2. Okay, so these are all the states and this is a sigma, that is A and B. Now Q0 for A. So Q0 for A taking transition to itself as well as Q1. So you have to represent in the set way. Okay, and Q0 for B. Q0 for B, it is taking transition to itself. So Q0 and Q1 for A. Q1 for A, there is only one transition B. So for A, we will represent the pi, that is empty set, empty. Okay, and Q0 for B, it is Q2, and Q2 it is not accepting any of the input. So it is both fine. So what is NFA? There is no mandatory that it has to take the transition for every alphabet symbol. That is a one thing. And here, whenever we are designing any of the language should be accepted by the designed machine. Okay, so it may be NFA, DFA, epsilon, NFA, whatever it is, the language, whichever the question they are giving, that has to be accepted. That is a thing. But in DFA, it has to take the transition, minimum one transition for each input, and no multiple transaction for the same input, and every state should take a transition for every input symbol. But in NFA, minimum string, if it is accepting enough, no need of taking more transaction. So in this NFA, that is also one of the advantage, that minimum transaction design will be there in the NFA. Okay.